problem, that's for sure. Okay, so 3.1. So now we're going to get into our algebra again. So simplifying algebraic expressions. And before we do anything, I have a whole bunch of little things to tell you about algebra, just to remind you, or even just show you from the beginning. So little tiny things to remember, I'll call it that, things to remember. Things to think about. We got to talk about a little vocabulary before we actually do anything. Okay, so expression versus equation. These get mixed up a lot. I could tell, I remember when I was in school and I would get them mixed up all the time too. So expression has no equal sign. An equation, you can even see the equal sort of kind of there, that has the equal sign. So expression would be like 3x. Equation would be 3x equals 15. That's the difference. Expression has no equal, equation has an equal. So look at what we're doing. We're doing expressions. So we're not doing equals. This whole section is on expressions like these. 2. 3 times y can also be written, which most of the time is written 3y or 2y or 2x or 5p. There's an implied, when you see something like, actually I have it right up top, right? 3x equals 15. It's implied that you have 3 times x is equal to 15. It's implied they're multiplied. So if you ever see 2 variables together, like x, y, it just means x times y. But this is how we write it in algebra. We don't really write x times y. We write it as 3x and xy, stuff like that. That just means multiplying. Three is what we've been working on. If you see a y squared, just like a number, it just means y times y. Or if you see an x to the 4th, that just means there's 4 x's multiplied. Just like a number, just with a variable.
Can you scroll back down a little bit?
Yeah. Which way? This way?
Down so we can see number 3.
Oh yeah, sorry. There you go.
Okay, I got it.
What? Hey, some terminology. That's just verifying a terminology term. All right, term in algebra means parts of an expression. That's not the real definition, that's my definition. So if we have something like 5x plus 3, this is my first term. This is my second term. Or if I have something longer, like x squared plus 5x minus 2. This is my first term. This is my second term. And this is my third term. So parts of the expression that are each little part that's added or subtracted together is a term. So each little part, if you take them all separate and make them all separate, they're each a term. So terms are separated by adding and subtracting, adding or subtracting. Another very important word is constant. And if you think about the word just constant, not even in math, if something is constant, it's always, right? It's always the same. A constant is always the same. So sort of like in math, it's the same thing. It's a term that is just a number. So if I have a number 6, it's a constant because 6 will always be 6. If I have a number 12, it's a constant because 12 will always be 12. There is no variable. It is just a number. Okay, so for instance, x minus 5. Okay, so we have to take the sign in front with it like a negative. So -5 is a constant. That was x plus 5, it'd be 5 as a constant. You always take, remember, a negative, a minus is a negative. So you have to take that with your constant. 16 minus 2x. Notice the 2 has an x, that is not your constant. The constant is 16. It's just a number all by itself without any variable. If I just have -8, well, that's my constant. -8 is the constant. Anybody need more time? Just shout and I'll hold up for a minute. Variable term. The term that has a variable. The term has variable. So 3x minus 2. 3x is the variable term. And then this case, -2, excuse me, -2 is a constant. Just to sort of put them together. And we have one more, maybe one more. Okay. Numerical coefficient. Sometimes you just say coefficient. I put it in this because these are my words. It is the number in front of any variable term. Okay, now, really important. It also includes the constant. And I think it's a little too early for me to sort of explain it to you because you have to know your exponents so I can really explain why a constant is. And I'm going to show you anyway, but let's say we have negative 8x plus 2. Okay, now, you never write this ever, ever. And this might go right over your head, and that's okay. But we have an imaginary x to the 0 power here. X to 0 power is equal to 1. So we never write it. So it's just basically 2 times 1, which is 2. But because there's like an imaginary x to 0 power, this is also a constant. If that doesn't make any sense to you, that's fine because we're not even there yet. But just know that the constant is also a coefficient. So the two coefficients I have here would be negative 8 and 2 coefficients. If I have 2y squared minus 9y plus 1, I have 3 coefficients. I have a 2, a negative 9, and a positive 1 for my coefficients. Let's just say, though, this is an interesting one, and I have p plus 3. I still have 2 coefficients. So basically coefficients in every term. But just like there's no x to 0 power after 2, there is an implied 1 in front of p. There is an implied 1 in front of any variable. That's just by itself. And so my coefficients are 1 and 3.
Why is it that there's an implied 1?
Because you need everything has a number in front. So if I have 1 times p, that's just p, right? Or 1 times q squared, that's just q squared. So anytime you see a variable with no number in front, coefficient in front, it's implied 1 because you really do have 1 times that number. And the reason we don't write it because 1 times a number is just 1 times anything is itself. So we don't write 1. We just put p or whatever variable it is. All right, so first thing we're going to do is something called combining like terms after all that definition. So we're going to talk about combining like terms. And it sort of is like what it sounds. We're going to take terms that are the same and we're going to put them together. You will hear this a lot in algebra. Even in higher math, we always talk about combining like terms because it's something you do all the time. Like you do this all the time. Okay, a like term would be the same variable and same exponent, or like terms, or what we call like terms. I got a few examples for you too. So in order to put things together, to combine things together, they have to have the same variable and the same exponent. If they don't, I can't add them together or subtract them or multiply them, whatever it is that we're doing. So this is all with adding and subtracting. So if I have 9x minus 2x, well, they're both x's. They both have the same exponent. Again, we don't want to talk about this, but really they're to the 1 power. Anything to the 1 power itself, we don't write 1. We just write x, but they're the same variable. They don't have an exponent. Exponent's 1, so I can subtract them. When I combine like terms, I can only change the coefficients of numbers in the front. So 9 minus 2 is 7, which means I have 7 x's left. If I have 9x and I take away 2 of my x's, I have 7 left.
So it wouldn't be x squared.
Now, x squared comes in when you
Combining?
multiply. When you multiply.
Oh.
X times x is x squared. Or x plus x would be 2x because there's 2 of them. So the difference between adding, subtracting, and multiplying is that you change your exponents. When you combine like terms with adding and subtracting, you never change your variable exponents ever. Only when you multiply. Good question. Good question. So yes, only when you multiply, which we're not there yet, so I'm gonna take basis, but only when you multiply. So you're not touching any exponent. You just, only thing you're touching, only thing you're changing is the number part, the coefficient part in the front. 2. 3x squared minus 2 plus x squared. Right, we can only combine things that have the same variable and the same exponent. So if I look at this expression, these are both x squares. I can combine them. This 2 does not have an x squared. I cannot combine that. I can only put my x squares together. And what we talked about earlier is there's an implied 1 in front of any any variable that doesn't have a number in the front. It's implied 1. So I have 3x squares. I'm adding another x squared. So that means I have 4x squares, and that minus 2 is just going to come with it because there's nothing I can do with the minus 2. I can't combine them. They are not like terms. I can only combine things that are the same variable and the same exponent.
So you wouldn't combine the both of the exponents to make it like 4?
We're not multiplying. No. It's almost like saying I have 3x squares. I'm adding 1 more x squared. So
Okay.
I only have 4. I have 4 of them. 4x squares. You'll see that when we get to multiplying. When we start talking about that. 3. 6 A's plus an A. Again, an A doesn't have a coefficient, my A here. So the coefficient is 1, implied 1. You can write 1 in if you want. You don't have to if you know it means 1. So if it had, and if you think about it without it, let me take it out for a second. There's 6 A's, I'm adding 1 more A. So what's 6A plus another A? That would be 7A. 7 A's, that's what I got. But you can definitely write a 1. And a lot of when we first start algebra, putting a 1 in front is a really good idea just to remind you it's a 1. So any variable that doesn't have a number in the front, coefficient, it's 1. 4. 3x plus 2 plus 5x minus 3. Eventually, this is going to get really long. So there's a little tip I can give you. Some people like it, some people don't. Actually, two tips I can give you. So let's look at doing two different ways. I'm going to show you now, so you can pick which way you like, if you like either of them. Okay, one way that students like is they can put the like terms together. They rewrite it like this. My x's in the front, and I put my non-x's in the back. And they combine it that way. So they'll go, okay, that is 3x plus 5x. Well, 3 plus 5 is 8, so I have 8x. And 2 minus 3 would be, okay, 3 minus 2 is 1, but 3 is negative, so it'd be minus 1. Or I'm going to write down for beginning. Some students like to use like underlining. So they'll go, okay, this is a like term and that's a like term. This is a like term and that's a like term. I'm going to put them together. So they look at the underline and they put them together. And they'll go, okay, so let's say underline 3x plus 5x. Okay, that means there's 8 of them all together. And then look at the double underline. X plus -3, that's -1 minus 1. You can also, if you like to underline a circle, I've seen students who use boxes versus an underline. You can circle parts. It's something you should try as we go on. Again, we're going to do a whole bunch of these as we go on. Try different ways to see which way you like. And that's what the way you should use. Find what you like, and that's what you should use. You can do, I'll do each one a different way. How about that? So I'll show you the different ways to do them. I forget number 5, remember 5. Okay, 5. Negative y squared. Here's your integers again, now in these plus 7 plus 3. So let's say I'm in the camp. Well, actually, this is really nice because the x squares are together and the numbers are together. So let's just say I want to make sure I put the right things together. I might do that, and I might do like circle these. So the underlines I put together and the circles I put together. And so here we go. Negative y squared plus y squared. So I want you to think of it in two parts. I know it's y squared. I'm adding the same things, right? Then just take the numbers in front. And this is me thinking. This is not me writing. I think, okay, wait, I have a -1 because it's applied 1 here, plus 3. This is me thinking. Okay, so -1 plus 3. Okay, that means 3 minus 1 is 2. 3 is bigger, so it's positive 2. So if I have negative y squared and add 3 to it, I actually have 2y squared. And then I'm going to put my circles together because they're my constants. They're my things without variables. 7 plus 3 is 10.
So I know you're showing us different ways we can like point out the separation, but
Yep.
I can just do it without pointing mine out. But do you want to see us pointing them out?
Nope, don't have to say them. If you can do it without it, I don't do them with it. I've been doing it so long. But what's going to happen for some of you who like this? Awesome. Like this is what you want to do, and eventually you won't have to do it anymore. So if you're to the point that you don't even have to do that, don't do it. Just do it. Combine like terms. Done. Done. Good, Megan. Like good question. All right. So I'm going to have you guys try this one. Don't worry if you're not successful. It's just a first try. Don't worry. All right, x to the 4th minus 2x squared plus 5x to the 4th plus 8x squared. Okay, let's see how you do. So I'm going to concentrate on the fourths. So I have two terms that have a fourth power, x to the fourth. And I know that x to the fourth without a number in the front is really a 1 implied. So if I have an x to the fourth and if I have one x to the fourth and I'm adding 5 more, that means I have 6 x to the fourth. And then I'm going to concentrate on my squares. I'll box them this time. Box. Okay, so if I concentrate on my squares, I have -2x squared and a positive 8x squared. So in my head, I'm going, okay, wait, 8 minus 2 is 6. The bigger number is 8, which is positive. So the answer has to be positive 6x squared. How did we do? Decent?
I got -6 instead of +6.
Probably.
I mean, I see what I did wrong though.
Yeah. It's really easy to make a little mistake. It really honestly is. This takes practice. Anybody else? And don't expect you to have it right off the bat. It just takes practice. So a little bit of practice here and there. All right, let's try this. 5 plus 8x minus 1 plus 4x. And this time I'll use the other technique that I showed you that sometimes like, again, you have to find which one you like the best. I'm gonna put the X's together and then I'm gonna put the numbers together. So I know that I can combine these first, then I'll combine these second. So 8 plus 4 is 12. There's 12x is, and then 5 minus 1 is positive 4 plus 4.
It doesn't matter which order that goes in, right? Like I could put 4 plus 12x, it's the same thing.
Oh, you're leading me right to the next thing. Yes and no. We're going to talk about something in a minute. We're just going to answer that question. So right now you're right. It does matter as we get on with algebra. Let's put it that way. Right now we're fine. Yeah, great question. That's your next thing
That's
we'll
how
talk
I
about.
did it too.
What's that?
That's how I did it also.
Yeah, it's not wrong. It's not wrong at all. And it wouldn't be marked wrong. And we'll talk about that in a second. Okay,
It's
last
just
one.
how the problem was. It's just how the problem was written. Like when they was like saying 4 plus 12x.
Yeah. 4 plus 12x. There's nothing wrong with 4 plus 12x. Except as we're going on, you'll see, actually it's my next topic. So just hold that question, but they're fine. They're fine. For now, they're fine. All right, they are fine. We'll talk about it in a second. Okay, so one more for you. 6, okay, my Z's look like 2, so I put a line through them. So if you ever see a line like that, doesn't mean it's a Z and not a 2. They look exactly like, my 2's and Z's look exactly the same, so I always put a line through them. Okay, so whatever way you did it, 7z plus 1. Got that? You did good. Anybody want me to show it, explain it? All right, so this is, I want to get you right away, like right away in algebra. I want to train you to do something. And that has to do with this question right here. Because I know what's going to come your way, and I know it's so hard to retrain something from the beginning. So it's like training, it's like any kind of training. If you train your mind a certain way, it'll always think that way, right? So I'm gonna turn the page and we're gonna talk about one last thing today, and that's gonna be something called standard form. When you do algebra, like we just did, combining like terms or anything in algebra, you should always write your answers in standard form. So they will not be wrong, marked wrong if they're not. But I know where we're going, and I know what you're going to do in development math 2. And if you do this now, you'll be set for where you're going in algebra. Answers should be written in standard form. Which means, okay, what the heck does that mean? What does standard form mean? Which means variable terms should be in order from highest exponent to lowest exponent with constant term last. As you're writing, answers should be written in standard form, which means the variable terms should be in order from the highest exponent to the lowest, with constant term last. That's what we call a standard form in algebra. Again, you will not be marked wrong if you don't do this, but I want you to start training your mind to think this way, because where you're going, this is where you have to do in algebra. We get to a certain point in algebra, you have to make sure everything's in standard form, or you're going to do it wrong. So if I could train you now, like to think this way and always do it this way, you're prepared, right? So if I have that written down, I'm gonna turn a page, but I'm gonna give you a couple examples, and then we'll call it a day. We're actually in a really perfect spot to stop. Okay, so put these in standard form. Okay, I have no combined, like we're just rewriting them in standard form. So these are already done. Like someone added these all, subtracted. So the answer they got was this: -2b to the 4th plus 5b to the 6th minus 4b to the 5th plus b squared minus 8. I know it's really long, but I want to show you how the exponents work. All right, so standard form means highest exponent to lowest exponent. So the highest exponent I see is right here. Isn't that the 6th power? That's the highest exponent I see. So I'm going to write 5b to the 6th first. Then I go to the next highest exponent, which is the 5th power. That's my second one. So I'm going to put minus 4b to the 5th. And then I look for my next highest exponent, which would be the fourth power, negative 2e to the fourth. And then I look for my next highest exponent, which is b squared. And then my constant term, which I don't know why I just did that, hold on. And my constant term is going to be my last term. That's called standard form. Highest exponent to lowest exponent, constant term is last. That's how you're going to see all your answers in books. That's how you see your answer everywhere. It's like a standard thing in algebra. That's what they call a standard form. 2. 5 plus x to the fourth plus x minus x squared. So that's the answer you got. You added like terms. This is what you got. Perfect. Now you want to think of it in standard form. So the highest exponent I have is the fourth power of x to the fourth. My next highest exponent, what's left, is my second power. Now we got to take that minus with it, or negative minus x squared. My third highest is my x, because that's really to the first power, even though we don't write it. And my last is my constant plus 5. That would be your standard form. You see how it's going from the highest to lowest exponent? So if I do the one we just talked about, which I forget the answer, so hold on a second. Oh, wrong one. There you go. There, we're on 12x. Okay, so if we do it back to the last one we just did, we had 4 plus 12x. That is a fine answer. There's nothing wrong with that answer, but it's not in standard form. Standard form would mean that the highest exponent I have is this x to the first power, which is 12x, and my constant would be last. And that's why I said it's a fine answer. It'll never be marked wrong. It's fine, but I really want to start getting you to put it in standard form from the very, very, very beginning. Usually you don't learn this till later on in algebra, but if I can do it now and you guys be that much better ahead, I want to do it now, standard form. 4. 18x.
Maybe this is just me, but ever since I was a little human being, I've always written my bigger number first.
See, there you go. I know, it's almost like, I don't know, look, to me, it looks cluttered if it's not all like in some kind of order. So that's why in algebra, they call it like standard form. So everything's in a certain order kind of idea. I like that. Okay, so you just look for the highest exponent. So the highest exponent I have is 3x to the fourth. And then my second highest, what's left, would be this x to the third. And then then I have this one, the square is my next highest. And then I have this one, the 18x. And then my constant is last. And that would be a standard form. Of course, we're not doing anything that big yet, but I had to give you all that so you can see the exponents when I'm in order. So when you do your work in MathXL, they're not going to mark it wrong if you put 4 plus 12x. They're not going to mark it wrong if you write it like number 2, 5 plus x to the fourth plus x minus x squared. They're not going to mark it wrong. It's not wrong. It's just, I want to get you doing standard form from the beginning.
But it would be wrong if they asked for it in standard